Well, I think we can start. Welcome back, everyone. So we're going to finish off Thursday today by starting off on doing an exam two review. And from a student that took the lead last class before we ended, I'll definitely ask one question. So it was asked if we can just at least do one. So I'll be the one that picks the first question, then I'll just turn it over to the class, see which ones you would like to take a look into next. We can spend a lot of time, like we mentioned before. We can spend the entire class period all the way up to 8:40 reviewing the exam. Or if we run out of questions, maybe we feel extra confident, that's okay too. In that case, we return back to the example we left off here. And the polling the class at the end of end of class time last time, that didn't seem to flow well, but at the end of class last time, we all decided we wanted an extra example. So that one's posted here as well. We may not get that one today, just depends on how much we review. But we'll be sure to complete all this stuff when we come back after the exam, anything that's left over. So back to the exam two review material. Don't forget that it will involve a TID4 calculator. We'll be using it in chapter 3, but just as a basic calculator for doing fast computations, finding percentages. Maybe for chapter 4 a little bit more because you might need the 5-number summary in order to construct the box plot. Then I kind of indicated the class that sure 5.1, 5.2 is important, but I can't ask a question from the entirety of the chapter. The exam would be too long. I'm going to focus on something very similar to the quiz where you're using the normal distribution, either normal CDF or inverse norm. So it's going to be a problem similar to 5.4 in particular. That'll be the third question, and the final question will be chapter 6, looking into a scatter plot, analyzing it, determining the form, the strength, the direction, and supporting your work also by calculating the correlation coefficient. So that's going to be the next big thing with the calculator. Excuse me. So a little bit more calculator work than before. So don't forget the calculator. I'll bring spares as usual, but it's always comforting to use the one you're most familiar with, the one that kind of worn grooves in yourself rather than a random calculator. But it'll have the same exact functionality as this if you do need a loaner calculator. Any questions about the exam in general before we take a look into some review questions? Okay, these review documents are posted in really kind of the same sort of way as exam 1. Version 2 is the same problems we've solved before. It's the lecture notes turned into bona fide worksheets, or they look more like quizzes at this point. Because they're problems we solved before, they're still good for practice. And no one memorizes all the problems verbatim. I feel like it's a good idea to look into version 1 because they're fresh and new problems. So let's look through this exam, sample exam version 1. That's this right here. And if I were to personally pick one problem that's going to be worth our while to review, I would go all the way to chapter 5, section 4. It'd probably be one of these. So let's look into one or the other. Actually, that one we did solve, Rochester, New York, 21 inches. I don't think we solved this one, or did we? Arsenic is a compound naturally occurring low concentrations. Hang on, let me take a look at these. Wait, this is the wrong document. Let me try again. Let me just close this one. This is version 2, the actual lecture notes. They all looked really familiar. This is the new problems. Okay, so we're back on track. Let me go back to section 5.4. That's too far. And I would pick one of these two as a good one to start us out. One that we definitely ought to review. Review the functionality in the calculator. It's pretty tricky in section 5.4 and how the problems go. This one actually seems familiar too. 500 gallons of water at a time. I think this is a redo problem. That one's the new one. Sorry, I thought these were all new, but this one's definitely new. So we'll start with this problem right here from sample exam, version 1. And what I'm going to do with this document is, if you want to come back to it, I'm going to post it probably just under here. I'm going to call this exam 2 review questions from the classroom, maybe a little bit better title. So these are the ones that we actually solved as a review session. So if you want to come back, it's just going to be on the bottom. And where am I? There we go. So here's how the problem goes. It says an article in Knee Surgery, Sports, Traumatic or Traumatology, Arthroscopy, so big title there, talked about the effects of provider volume on resource utilization for surgical procedures. And it showed a mean time of 129 minutes and a standard deviation time of 14 minutes for ACL reconstruction. So that's a bad ligament to tear in your knee at high value hospitals. It says next, assume that the ACL reconstruction surgery at high volume hospitals follows the normal distribution. I'll say ACL, but it's anterior cruciate, probably saying this wrong, ligament. You know, one thing that exam is actually going to say would be, to start it off, there'd be a part A that goes, where's caps lock? There you go. State the value of the parameters and use the correct symbols for each. So let's make a slight revision there to make it more similar to a real exam question. By the value of the parameters, the symbols we're going to be using is going to be a symbol mu and a symbol for sigma. Anyone see, for example, what the value for sigma should be on this problem? Sorry, say again? 14. Yeah, absolutely. Right where they said standard deviation of 14 minutes, that's our sigma value. Then likewise, when it said mean time of 129 minutes, that's the value for mu, the population mean. Or at least this is the value we're going to estimate the population mean by. The best information we have is 129 minutes. I remember this is someone that tore up their ligament in their knee and they're under anesthesia probably longer, but they're working on for 129 minutes on average. Standard deviation is not very big on this. It seems like they have ACL surgeries kind of down pat. I would expect a higher standard deviation because everyone's different, but they seem to know what they're doing on this. So this is what the problem would really start off as, is a section 5.4 normal distribution problem. A lot of the problems are going to ask you to include a graph. And if you don't, then maybe I'm going to assume you ran short on time, or maybe you're really confident. We mentioned this is mostly for partial credit, really. So let's start with this step. Let's graph this out. The graph for the normal model would look about like this. Notice we're not going to use the 68, 95, 99.7 rule on the exam. Really, that was a kind of just a way to start helping us visualize where things are, how to draw these graphs and work with them. So this is N 129, comma 14. 129 would go down here. And now that we have the graph down, we do want to add a little bit more information. The more you add, the more it starts to look like the information in the problem, the more partial credit you would get. We're being asked, what percent of the time does ACL surgery at high volume hospitals take less than 140 minutes? So this is the big punchline of the problem. If we say 149 minutes, let me try to get my numbers in the right region. I remember struggling with this last time I did this. 129 plus 14 takes us to 143. So that's about where one standard deviation would be. 140 minutes is just slightly to the left then. So here's 140 minutes. I don't necessarily have it placed perfectly, but I'll try not to be way off like we did on the extra example when we did this in chapter 5. So this is going to be the answer to our question. This is an area, it's between 0 and 1 every time we calculate it. And we'll just multiply it by 100 to get the percentage once we find the area. This is the other critical thing we have to remember for the purpose of the calculator. And a good strategy for the page of notes that you'll bring is you can put down your own personal instructions on what goes into the calculator. For example, when it says what percent of the time, what would you all say this is? Normal CDF or inverse norm?
That's number 2.
It is option 2, absolutely. So option 2 was the normal CDF. So the dead giveaway was the word percent. We mean the percent of the area under the curve, and areas are given by that particular function in the calculator. So first thing you might want to put in your page of notes is you have to click second and bars to get it started. Then you have to pick the right function, but it's absolutely function 2. And there's several inputs we have to put in. We didn't say too much on this graph, but again, anything you add that's a bit extra to this is even more partial credit. I'd probably put down here input 1, which is lower, is going to be negative 10 power 99. That's because the area goes to the left without stopping. This is inputs 2, the upper value. And mu and sigma is already printed out. We already said what mu and sigma was, so it's not as critical. These are the 2 major things that we're worried about. So at the negative sign, 10 power button is this up arrow, 99. Go up to the cutoff where the area stops, 140. Value for mu is the 129, so drop that in. And for sigma, it's 14. So that's what our calculator ought to look like before getting the area. That's the exact area. And it looks a little bit better than some of the other problems I was doing where the areas felt way off. We're close to about 75% if we're close to 1 standard deviation. If you gave me this number, I'm not too worried about that. It's the right value. It's just a different unit change. In MyLab statistics, sometimes they're specific. They really want a percentage. So to follow the instructions to the letter, when it says what percent, go times 100. We're now at 78.40. Did it say what to round to? It did not. I usually try to include those instructions on the exam. If it doesn't say what to round to, it's up to you. If you rounded to the nearest percent, 78%, that'd be okay. I think more standard is to round to 2 decimal places. So to 2 decimal places, it is 78.40%. So this answers the whole question. Again, if you have time, it's a good idea to just write down the graph. It's like insurance in the problem. If I mess something up, if I accidentally put in instead of 140, maybe just some weird number, or if I got my parameters backwards on accident, this is going to be way off. But from this graph here, I would probably award most of the points in partial credit by doing this organization. I would just assume there was just a slip up in the calculator. Well, any last questions, folks, on the part A there? Okay. The other interesting problem is when it gives us a percentage, it wants what amount of time describes the time to complete the 10% fastest ACL surgeries. One thing I did put on this axis is that this is, for the horizontal axis, time to complete the ACL surgery. And sure, it's definitely optional, but when you're trying to put all these thoughts together, having that there is helpful. Because if we write down another normal distribution, this is once again and 129, 14. 129 for the mean, 14 for the standard deviation. Writing this down and thinking of this as a horizontal axis, time to complete the surgery, we can get a better feel for what 10% fastest is going to be. So we have to shade one side. And if it says 10% fastest, we'll shade to it's either to the left or the right. Anyone see what it should be by the context? Yeah, go ahead. Yeah, absolutely. It should be the left-hand side, right? Fastest means less time, so we're going to be somewhere here towards the left. And the lower 10% was probably, it's hard to put down exactly, especially since my curve isn't perfect. But I would probably put it down there. A little variable x, because we are actually solving an equation. It's not a bad idea either. And these problems are tricky for a couple reasons. Even if the question was about area to the right, you have to put in your calculator area to the left. So putting in the center of 129 is just us being sure we have the right value. The second thing that's tricky is this 10% has to be converted to a decimal. So the decimal point is here, move it 2 spots to the left, and now it's a 0.10. And this is input 1, the area. So with this setup, area is 0.10, it's area to the left, so we don't have to flip things around. We can find the 10% fastest surgeries. So that doesn't necessarily mean they worked the best. Maybe that was a rookie doctor and didn't do everything they're supposed to. And so it was a fast surgery. It's hard to say for sure. Or maybe the ACL was just easy to deal with. It was a micro tear or something like that. Either way, hit second vars to pull up the normal distribution again. This time, other thing I forgot to mention is if they give you a percentage, this means we'll use option 3, input 3, use inverse norm. So if they ask for the percent, you're on normal CDF. If they give you one and you're looking for a value on the horizontal axis, that's the inverse norm function we'd have to use. Those are the only two that we're going to be using on this panel. So click on inverse norm. The area is, as a decimal, 0.10. Same values for parameters, 129, 14. And calculator setup like this should get us to where we need to go. We get a value of, let's see, it didn't say what to round on this one either, but it would come out to, let's round to 1 decimal place, 111.1 minutes. So that solves a problem on this one. Box could be used to emphasize that this is the answer we're going for, but it's totally optional if you'd like to do that or not. Kind of looks funny in a way, but it's all pretty much important. If all you gave me was the 111.1 minutes on the exam question, then that would be for full credit. I'll assume that you're just really confident you know exactly how that calculator goes. But this would be the definite thing I want you to review. Other things that you might want to review along these topics are, you could see how we did in class on the second exam version 2, or go over your quiz again. For quiz 5, it's basically this problem with several parts. If we take a look at that quiz, just because it's relevant to the exam, it's the same kind of stuff in a sense, slightly more questions. But this is about how a real exam question is going to look as well on exam 2. We'll state the values of the parameters coming from the information above. What percent means use normal CDF. And it says here, what percentage? Again, it's a normal CDF problem. And when it says down here, very below, 10% worst cases, this is now on the upper end, and we're just using inverse norm. So same type of questions as well on that quiz 5. Well, any last questions, folks, on getting through the chapter 5 topic, normal distribution? As far as the grading of quiz goes, I have some that have been received by email. I'll be grading them on Friday, and that's going to be one of the first things I do on Friday, catch up with the grading. I'll email you your graded quiz right away. If you turn in a hard copy today, just watch your ISU email still, and I'll scan that copy emailed to you, so you get that feedback ahead of Monday's class. And same concept with quiz 6. Quiz 6 looks like this. It's a chapter 6 problem. So same kind of stuff as we've done before, slightly different kind of context on this one. Looks like this one's about psychology and satisfaction with life scale. That's a real scale that they use in that discipline. If you solve this quiz early, say you solve it sometime on even Sunday late at night, when I wake up on Monday, the very first thing I'm going to do is get caught up on grading quiz number 6, and I'll email you back your feedback. It means you might have to send this to me by your ISU email to get that feedback. But if you want the feedback really on this one, see how you're doing on chapter 6, I'll be happy to give you that right away. Well, this is the point of where I'll turn it over to the class. We looked at a chapter 5 problem, and at this point, other good things you might want to look into are chapter 3 is going to be pretty much something like this. I didn't include any graphics because the major takeaway from chapter 3 is going to be computing these kind of percentages here. Chapter 4 is going to be a little bit with the calculator. You need summary statistics and then build a box plot. We did chapter 5 and chapter 6, pretty similar to the very first question, 26 right here. This one is pretty similar again to the actual quiz question as well. I'll leave it up to the class. Any direction that we should go to next for further review? Yeah, go ahead. This one right here? Yeah, absolutely. I think it's going to be similar to the quiz where there's 4 parts in total. Part A is going to be parameters, and then maybe 1 or 2 questions with normal CDF, 1 or 2 questions with inverse norm, but otherwise it's going to be very similar, formatting and everything, just a different context. Other questions? Yeah. No worries.
Hold on.
Correlation, coefficient,
Thank
right?
you.
Yeah.
Is
Yeah.
that-
Yes, it will be. So that would be something that we have to know how to do on the calculator next. And that kind of takes us to this one. Wait a minute, it doesn't actually ask that. Let me see if we've got a stronger one. That'd be more like this one right here, directly asking for the correlation and interpreting the correlation using the context. So should we do this one next then to give it a try? Okay, again, this one's pretty much like quiz number 6. I think quiz 6 has 3 parts. So this one is doing double duty, so same kind of concepts. Let's import this in. And here's our next review topic. So in the study of the tufted titmouse, this is just a bird, Parus bicolor, an ecologist captured 7 male birds, measured their wing lengths, and other characteristics. So these are the 7 birds they captured, and that's such a strange name for a creature. Let's take a look at what this even looks like. Again, if you're doing this as a quiz, this is a pretty good strategy all on its own. If you have a picture in your mind of what you're working with, the problem feels a lot more concrete, less abstract. So that's our bird. We're studying kind of information about this bird. It looks like we're interested in their wing length and branch diameter on the things they perch on. So it's kind of an interesting looking bird for sure. I don't know if these are in Idaho at all, North America, so maybe. So back to the problem. The ecologist captured 7 male birds, measured their wing lengths and other characteristics, then marked and released them. It said next, during the ensuing winter, he repeatedly observed the marked birds as they foraged for insects and seeds on the tree branches. So this person is just bird watching all day, it seems like, but probably has assistants as well. He noted the branch diameter on each occasion and calculated from 50 observations, average branch diameter for each bird. So this is an enormous undertaking. 7 birds were captured, then they were observed. He looked at 50 observations on what branches they perched on, then average the diameter after doing all that work. So I'm imagining he's going out into the field and taking measurements. And these are the results. So this is like a magnum opus of doing a huge study. So we have different wing lengths, different branch diameters. We put this on a scatter plot. Let's size this up a little bit better for class viewing. We have wing length going this way, branch diameter going this way. And one question I did ask on the quiz, I believe, which is also another exam question, would go like this. So let's change up the parts just a little bit. Determine which variable is the explanatory variable and which is the response variable. Then this would be our new part B, our new part C. So, like we mentioned, there's usually no tricks behind this. The explanatory variable can oftentimes just be spotted by the way the table's formatted or the way the scatter plot's formatted. We just have to name it. Anyone see what it would be?
Wing length.
Absolutely. So on these kinds of data, it's common courtesy to always put your explanatory variable first. And at the same time, if you're seeing the scatter plot, it's required your explanatory variable is on the horizontal axis. So it's always going to have that kind of correspondence. Sometimes you can kind of suss out what's the explanatory, what's the response by thinking about the problem. Other times it's a little bit vague on what's supposed to predict what. But the scatter plot is a giveaway, so is the table. I'm never going to switch these columns like we mentioned before. So this is kind of usually a faster part. It's going to be wing length. Likewise, there's only two variables. So if you've nailed one down, you know the other one as well. The response variable is branch diameter. It's always the second column, and it's always the vertical axis it's associated with. So for a response, we just have to say branch diameter. You might write out the explanatory variable is the wing length. The response variable is the branch diameter. But if you're saving time on exam, I just have to know which is which, and an arrow definitely does the job there. Saves a little bit of writing. Next, we're going to compute the correlation coefficient for these data. If we were to put a line through it, we don't necessarily have to. That's a chapter 7 topic, but it kind of helps us see about what this problem is all about. We're trying to predict what branch diameter this bird wants to land on based on how big the bird is in terms of just its wing length. So this might be a good line that predicts that. Next thing we want to know is how strong is the relationship? How strong is the correlation? And that's the so-called correlation coefficient R. So aside from chapter 5, where we're dealing with the normal distribution, this is like the next major thing that we're putting into the calculator. The good thing about this is it's familiar, however. This is like calculating one variable summary statistics, where you go to hit the stat key to start it off, hit enter, and you're just putting in two variables, L1 and L2. Whatever the explanatory variable X is, that's always going to be L1. Actually, it might be better to put it here. L1 is always associated with X. L2 is always associated with Y. So it's a tricky topic, honestly. Even though the formatting always goes the same, there's like 9 different things here. There's 6 different things here. There's XY, there's L1, L2, and there's explanatory variable, response variable. But the correspondences are always exactly the same. L1 for the explanatory variable, which is X, L2 for the response variable, which is Y. So up arrow and clear to wipe out all the data from the last problem. Now we have to carefully put this into the calculator, and we do have to be pretty careful because this is one of those kind of problems where it's impossible to give partial credit. If I mess up one number, your correlation is going to be pretty close. And I would give probably full credit to that. If you're off by just like a tenth of a decimal, something like that, no big deal. But the correlation was supposed to be, say, 0.75, and you gave me 0.65. It's now pretty off. That kind of goes backwards with what I said. If it's, say, it's supposed to be 0.75, but you gave me a 0.45, that'd be more reasonable. That one's now actually pretty off. Or if you saw this and gave a negative correlation coefficient, that's even worse. In those kinds of cases, we could lose a lot of credit on this one. So the major skill here is import the data very, very exactly and carefully. The more time you spend on this, the better. So I'll get quiet as we're finishing the import. You don't have to put in the point zeros, but you do have to put in the 0.5s. Okay, I think I've got the data in. You know what? There's an actual check on this. Even though grading on Part B is kind of finicky, it's hard to award partial credit on this. There's a way for you to check your work. See if your scatter plot looks about like this. Even though actually producing this scatter plot is not required, that additional skill that was used in MyLab statistics is pretty helpful here for checking your work. So it's easy to get the data wrong, but it's fast to check out if you're close or exact. The trick is to build a scatter plot, hit the zoom key. We want the zoom stat option. So that's option, I always forget, option number 9. So after you import the data, hit zoom, punch in option number 9, and this is the scatter plot. Erasing the line just so we can compare them more closely. There's a grouping of 3 that corresponds, one in the middle that looks about right, another grouping of 3 that looks about the right shape. I would say by the scatter plot in the calculator, the scaling might be a little bit different, but it's the same basic picture. So I would say I probably did put it in correct. If you have something a little different, like if this point is slightly higher, or if this point moves slightly to the right, then that would be just a small error in the calculator here. It will affect the correlation coefficient, so it's good to just double check. So that's nice. It's rare to have such a nice check on the data that you imported, like just looking into the scatter plot in that way. The next thing we'll do is actually calculate the correlation coefficient. This is where you hit the stat key again, as if you're entering the data. Go over to calculate, and the option that we are using is all the way down on option 8. Again, all of these have paper trails in the notes. If you go back to the Canvas webpage in chapter 6, there's the step-by-step guide broken out on a table. And when you build your notes for the exam, these little calculator guides are good things you might want to put on the notes just for an extra assist. So this option here, it actually gives us the equation of the line, but that's chapter 7, but also gives you the correlation coefficient R. So hitting enter on that option, the correlation is 0.80. Didn't say what to round to. I don't know why I keep forgetting to do that on these kind of notes. I think 4 decimal places or 3 is pretty typical for a correlation. So the value is 0.8033. Then this is something else you might want to have on your notes. We're going to interpret the correlation coefficient using the context of the data. So you want to say, is that a weak, is that a moderate, or a strong correlation? So go back to chapter 6 and but the entire chapter 6. And in chapter 6, there's a scale somewhere down here. Oh, that's the calculator step-by-step guide if you want to see how to reproduce a scatter plot. And finally, down here, we took a lot of time in this section. Here's the scale that we're looking into. The fact that R is positive looks right because this is going in the positive direction. So that's helpful to see. And we are in pretty much the boundary point. If you said moderate to strong on this, that would kind of make sense, but it's just a little bit into the strong range. So I would personally just call this a strong relationship based on this scale and the value we calculated. It is a rule of thumb, so if you called it moderate, I would say that's acceptable as well. We just couldn't say, sorry, get that out of there. We can't say weak by any measure. It's at least moderate, more likely a strong relationship. So now we can interpret the correlation coefficient. And you know, I think for the actual quiz problem and the exam question, it goes a little bit differently. So let me reword another part here. Let's go part C. It's kind of annoying. Let me fix that. Let's call this a part D. I think another thing I asked on the real exam question as well in the quiz was to directly interpret the scatter plot itself using the context. Interpret the scatter plot, mentioning the form, direction, and strength using the context. So this is a question that you should expect on the real exam. Yeah, that's the upcoming quiz number 6 right here. Again, it's kind of unfortunate because this one has a due date of October 23rd. But this is one if you did decide to solve early, say maybe on Friday, Saturday, or Sunday, I would grade it early for you to get your feedback right away. Exactly, yeah. You'd have to send it by email, but I'll just email you back the feedback. And so the quiz here is just a different kind of context. It says calculate the correlation coefficient R. That's what we did. Then describe the direction, form, and strength of the scatter plot provided using the context. That's the kind of rewording I'm trying to put into this problem just to make it feel more similar to both the quiz and the real exam question. So slight change of plans. Sorry for going a different direction. Let's just directly copy this in, match up that wording. When I say interpret the correlation coefficient, it's not like that's a bad question, but this is just a little bit more direct. Hang on, where am I? Okay, we're over here now. So let me just put here an overall part C that goes like this. More similar again to the quiz and the exam. I think that makes it a little bit more helpful. Sorry for the quick change around on this one. So now we're ready to finish off this problem. There we go. So it says describe the direction, form, and strength. Big thing we have to make sure we hit is talk about the context. But the context is basically mentioning the explanatory variable and the response variable. Even if you didn't mention the name of the bird, I would say you don't have to say every single thing about the context. When you're talking about wing length, you are talking about the bird. So we could say, as far as it goes with direction, yeah, that's a good word. You could say either association or the relationship. Let's go the association between, let's mention the variables, wing length and branch diameter.
Would it be a good rule of thumb too to mention like if the explanatory value variable is mentioned first, to do it in your description too?
I'd say it absolutely would be, yeah. Keeping everything in that normal pattern would be a great call. I wouldn't take off points if we did flip around, but you know, in chapter 7, that can kind of mess us up on some of our other practical interpretations where the order was actually pretty important. So just as a good practice, yeah, I'd always go explanatory first, then response. So we can say association between those variables. You could say the wing length of the tufted titmouse and the branch diameter that they perched on, but it's okay to be a little bit terse. The right up there does convey the additional information. We want to say the direction. It's positive because it's going up. Also, our correlation is positive as well. So we can say is positive. This is where we mentioned the direction. The form we want to mention as well. And, I'd say it's a pretty linear form. It could potentially be nonlinear, but we didn't look into a lot of nonlinear graphs. I think more likely, it could be most likely to be linear. But watch out, if the points seem to go in kind of an obvious and blatant, say, U shape or something else, you would need to say nonlinear, like we saw in some examples in the notes. But if a line makes sense, like we put down, we'll say for the form, it's positive, linear. So this is the form. And next we mentioned the strength. That's where the correlation coefficient comes into play, as well as the rule of thumb. So we could say, and the strength of the association is strong. If we got, say, 0.30, this would have been a bigger scattering of points. We would have just said is weak instead for that kind of a correlation coefficient R. So that's kind of the main wrap up of the things that we did in chapter 6. In fact, we did a lot of stuff in chapter 6. If you scroll through here, or if you look into the sample exam, there's lots of other things going on. Sorry, I'm on the wrong document. Oh no, this I put down on the actual sample exam 2 problems. Let me fix this by just taking a whole screenshot. 2 Word files, I guess, just kind of mixes me up. It was meant to go over here on this document. I kind of started that. Okay, now it'll survive. Here it is once again. I think I lost my train of thought. Oh yeah, so chapter 6 is pretty big. There's a lot of other things we did on this chapter, but a lot of this kind of stuff here is kind of like the practice for what the quiz question looks like, the exam question looks like. Doing these for additional practice, there's similar problems on MyLab statistics, is still pretty helpful, but the main question you should expect is like the one that we just solved. Something like this one. Yeah, go ahead.
When I think situation, I think of like basically being all the points are together. So like in the line.
Yeah, absolutely.
Yeah, does that make sense?
It does, yeah. So for these data, the correlation came out pretty strong. But I think we had another one that goes a little bit more like what you're saying. If we took a look into something with a really, really strong, it would look about like this one. And we never actually calculated the correlation on this. So just for the sake of extra practice and seeing the difference between what does, my rule of thumb is down below there. What does strong really look like if we're on the upper end? Remember, ours was kind of on the border, actually. It's between moderate and strong. And so I kind of agree with you. This is pretty good scattering. So if you said it's moderate and as opposed to strong, that would be pretty good judgment on this. Strong is supposed to look like the points are all practically on the line, like the problem above. So let's take a look into that. Sorry, I have too many documents open. It's this one here. Let's take a look into this. Do correlation again on this problem. We've never done it. We just claimed it was close to -1. So another run through. First thing to do is hit the stat key, hit enter and clear out data. Up arrow and clear does the job for us. This table is going horizontal, but same idea. First variable is explanatory. I switched the order I asked the question on this one. I guess that's something that's always fair game. But the table, I'm never going to switch the order. The thing that comes first, either top down, left, right, is explanatory. That's what goes into L1. So it's 300, 650, 900, 1250, 1500, 1850, 2100, 2400. Then on the next, 18.1, 16.2, 14.9, 12.5. Let me know if I mess up a value, 10.8. My big mistake on this is getting the decimal point in the wrong spot. And that absolutely will throw a lot of stuff off, especially the correlation coefficient R. So don't forget, there's a big check on this. When you do this on an exam setting, we built this one by hand, but I'm going to give you an actual printout. Click zoom, go down to zoom stat, option 9, and see if it looks about right. I think our by hand sketch is pretty close to this. What you're looking for is one point that like zoomed up or down, left or right, just doesn't fit the pattern in the provided scatter plot. If it all looks right, hit the stat button again, right arrow to calculate, and we're going down to option 8. So this is going to resolve, hopefully. What's the difference between this, where it was barely in the strong field, but maybe it looks more like moderate, as you're saying, versus this one? This one I would say is an extremely strong relationship. Correlation should be negative, and that's what it looks like. Negative 9.9989. If we rounded on this, it would have been negative 9990. So the points look like this, very little scatter along the line whatsoever. That's when you're getting the hugely close to the upper end, one side or the other of this scale. Around -1, around +1, that's when the points are basically all on the line with just a barely little jitter up and below. This one still, just by the rule of thumb, we call it strong, but definitely on the very most weakest end of strong on that rule of thumb. But does that help to see the difference between those two different, really very different kinds of data? Awesome. Yeah, go ahead, sorry. Oh yeah, that's a great thing to mention. Thanks for talking about that. So I can't help with calculator issues on the exam, but something like that, I would call that a setting issue. That is something I would help with. If this was at home, where you want to go to is the correlation coefficient one-time setup is the document that helps. But this is what your calculator needs to show or needs to do. So if you all have that same kind of issue, if R is not showing up, click on second and go to the number 0, the catalog function down here. Then what you need is just hold down the down arrow key until you get to the D's, looking for diagnostic. Somewhere down here, there it is. You want this option, diagnostic on. Did you see it on the list? No worries. Once the arrow's pointing to that, just hit enter a couple times until the calculator says done. So it should look like that. Now, if you go back to stat, calculate, option 8 here, and run through the information again, you should get the values. Awesome, I'm glad that's working out. That's really weird. And if anyone like resets your calculator or borrows it, this will go away again because that's the default, not to show it. Don't ask me why. They just decided that people didn't want this for some reason. So again, if there's a setting issue on your calculator, or like if you go to stat and all this is messed up and you forgot how to restore it, those kind of technical support kind of things, I'm very happy to help with on an exam setting. And if I can't fix it, I'll just hand you a different calculator that's working normally. Other questions at the moment? Okay, well, we looked into kind of the major stuff on exam 1 as far as the calculator use is going to be. Normal distributions, quiz 5. Scatter plots correlation is quiz 6. Other stuff is doing some percentages on a contingency table or doing a box plot. This one does have some calculator work on the 5-number summary. So I'll leave it up to the class. Any other questions folks would like to take a look at? Either chapter 3 or chapter 4?
Is there gonna be a chapter 3 question on the exam?
Yeah, there will be. Sounds like that's probably a good next one to go for. Should we try this one out? Okay, let's give this one a try. I remember this being tricky. I think, yeah, and I think I actually messed up a problem when we did this for the first time in class. I got one of my denominators wrong. So let's run through this again. It's going to be really focusing on these kind of things, finding the percentages from the tables. There's a little bit of other stuff in chapter 3, but this will be the main thing on the exam. So this will probably be our last problem for the day. What's going on with my formatting here? Okay, that looks a little better. Okay, so here's that question. Of course, there'll be actual spacing on the real exam. You'll get a table kind of like this, just a random context. This one looks like someone who has some kind of Python hobby of some kind. It says, how is the hatching of water python eggs influenced by the temperature of the snake's nest? Well, it looks like more like a biology kind of situation. Researchers assigned newly laid eggs to one of the 3 temperatures, hot, neutral, cold. The hot condition duplicates warmth provided by the mother python, so in nature. So this is probably where we expect them to do the best. The neutral and cold conditions mimic the mother's absence. That's kind of sad in a way. So what are we looking at? Here are the data on the number of eggs hatched. So there's 2 categorical variables this time, cold, neutral, hot, where hot is more similar to conditions in nature. And this is the absence of the mother's python's presence. Other categorical variable is whether the egg hatched or did not hatch. So all of these are the sad cases. These are the dead water python babies. These are the ones that survived some way, somehow. It's a 2-way table because of the 2 categorical variables. We have row totals going this way, column totals going this way. First, we're describing the individuals. And I think the question I would really ask here is also describe the variables. I think that's a pretty similar question as well. I forget which one I focus on the most. The individuals are going to be the individual eggs, some of which hatched, some of which didn't, some in favorable conditions, some in not so great conditions. But we can say here, the individuals are the 187 eggs. You could be more descriptive, but again, as long as you're mentioning some part of the context, that does the job for this. So we know it's the water python eggs in particular. The variables is kind of a callback of what we did way back on exam 1. But for chapter 3, in a contingency table, they're both categorical. We just have to give them a name. So we can say for variable 1, let's color code them this way. Variable 1 will be this one, cold, neutral, hot. We just need a name for that. The name isn't cold, neutral, hot. That'd be a strange name for the variable. It might just be something like temperature. This is categorical.
Good.
Sorry, say again.
That one is?
Yeah, this one would be categorical, which you know what is kind of confusing in a way because we're looking at numerical values. So the thought on how to think of this as a categorical variable is, imagine you were in charge of these 187 eggs, and this is what your data would actually look like before it became a table. The original data, let's throw this on the review as well, because this is a tricky topic all unto itself. Let's move that to the left. The original data table would look more like this as we started to build it. The first column would be for the individuals. So this would be Python egg. They might be coded some way, maybe a serial number, some kind of barcode reader device could read, or they could just have numbers, maybe drawn on with a Sharpie, something like that. will be 1, 2, 3, and so on, all the way down to 187. Let's write down 4 up to 6 individuals.
No, you're good. What messed me up was I thought we were gonna have one of each, but
Oh, gotcha. The one of each is going to be more the chapter 4 when we're dealing with a box plot. In that case, you can have one that's quantitative and then another one that's categorical. Then the next column is going to be temperature. The next column would be hatched, the other categorical variable. And just to show what the data would actually look like, we might have hot, and then we might have no for hatched. Those exist. There's 29 did not hatch under the hot condition. Maybe a hot and a yes. It might not be all the 75 hot conditions first. It could be mixed up. I think they might be in order if you're collecting this in a reasonable way, but if the data is kind of mixed up, the next one could be neutral. Yes. Neutral, no, and maybe cold. No, cold, no. This is what the table would look like with one additional thing. It would have dot, dot, dot until we get to 187. And maybe that one was a hot with a yes. And the dot, dot, dots are just to convey this goes for a little while. This is what the original data would look like. So if you're the head researcher or just the person tallying up all the data, this is what it would go in. Let me see if I can get that to work. Oh, it's kind of pissed off at me. There we go. Doesn't want to paste inside the table, I guess. So we have, for one variable, temperature. It's categorical with categories cold, neutral, hot, and the other variable are these two outcomes, whether it hatched or not. I put it with a question mark because hatched is a category, so I need something like something to differentiate it. You might just write down success or something like that. Going with hatched, this one is also categorical. With categories, hatched, did not hatch. So that's just kind of the breakdown of what we're looking at when we see this data table. The fun part is actually getting these percentages out. So I'm going to copy the table not a whole bunch of times like we did before, but just once so we don't have to scroll up and down as we look at the questions a whole bunch. Here's the computational part, looking into these percent type questions. We mentioned before, anytime you are asked a question, what percent, this is just the same thing as a probability. The idea is, if you were to randomly select one of these 187 eggs, what is the probability the egg did not hatch? We're just going to write it as a percentage instead. When it says what percent of the eggs, we're talking about all of them, 187. So that would be the denominator in this case. And we'll see what the numerator ought to be. Yeah, exactly. We go, it's the 11, 18, and the 29, but the 58, the row total here, gives us that computation altogether. Then go times 100% to turn it into a percentage. And this is pretty much all we're doing in this problem here. We mentioned before, they are tricky, so let's be careful with the next ones. I remember one of them tripping me up the last time I was doing this with the class. So we get here 30.01%. So these are the ones that did not survive. And for the next follow-up question, what percent of the eggs did not hatch and were in a cold environment? This one's a little bit different. When it says what percent of the eggs did not hatch, we're talking about the percent of the 58 right here. That means this one is going to be our denominator this time. When it asks we're in a cold environment, we would put in the 11. 11 of them did not hatch and we're in the cold environment altogether. But notice the change, different denominator.
All right, I'm glad we went over this because
Actually,
the answer on your quiz,
yeah,
the way that it's worded, that's what I thought was right. But on the quiz, it has 11 over 187.
you know, I think that answer is actually the better answer to this one. I was looking at this when it said what percent of the eggs. That's talking about the 187 again. So same kind of issue right here. Let me see if I can highlight this in a little bit better way. What percent of the eggs, and the condition we're studying is did not hatch and were in a cold environment. No, I think that's right. Thanks for pointing that out. I think I did it correct the first time I looked at it. That should have been the 187, 11 dividing into that. What tripped me up was reading this wrong, thinking it said what percent of the eggs did not hatch and we're in a cold environment. How could we make that be 58 down below? I think the wording would have to go like this. To put a 58 in the denominator, my wording must say among all eggs that did not hatch. That's going to really direct us towards the actual 58 that I thought the first time I looked into that problem. Among the eggs that did not hatch, what percent were in a cold environment? So in that case, 11 of them were in the cold environment. When it says among all eggs that did not hatch, that would have been the 58. Then times 100% on that one. This one, again, like we mentioned, we have to be really careful of these. These are very tricky. They're easy to kind of lose your way on these and interpret it incorrectly. This one's just talking about what percent of all of the eggs. So 187 goes into the denominator on this one. Does that make sense to folks on seeing the difference between the two? Okay, so don't do as I did. Be very careful with the way it's worded. The start of the problem is kind of telling you what's the denominator in the very first place when we read these out. So with this one, let's put in the correct answer first, 11 over 187 times 100. And we have some similar comments that we made elsewhere on the notes. The whole answer is, what are we rounding to? 1 decimal place, 5.9%. So if all you give to me is this, you've got the full credit. But if you show me the whole fraction, I now have the opportunity to base partial credit on this. So if I know what your numerator was, what your denominator was, I can give it a little bit more. And if I accidentally go 11 over 58, I would still give partial credit to that. You've got some of the problem in. But if all I get is a random percent and I'm not sure how it came together, then we could lose a little bit more credit on that kind of question. But by the way, we might as well finish that off. 11 over 58 times 100 comes out a lot different. This would have been 19.0% upon rounding. Well, that's 2 tricky questions already. Any questions at the moment? Really 3 of them when we look at all of them together. Let's see if we can get to the next couple. I think that's the last of the 2. We should be able to finalize this problem here. So here's our data table below. Let's look into part D. Among the eggs that were in a hot environment, let's highlight this in yellow with the idea of trying to be as careful as possible on these last ones. What would y'all say is the denominator based off that wording so far? Absolutely, good call. When it says among eggs in the hot environment, the whole thing we care about is those 104 eggs. And we're going to find the percent of them that hatched. Well, that's the other variable. 75 hatched that were in the hot environment. So multiply this by 100%. And here's what we get. 75, don't multiply, let's go divide by 104 times 100. We get the number 72.1%. But imagine maybe I did mess this up in the calculator somehow. Maybe I just put in the wrong numbers. Maybe I accidentally multiplied, just kind of hit the wrong key and just put in a random number here. If it's correct on paper like this, that's a ton of partial credit. If I see the right fraction, but you made a mistake putting into the calculator, let's say this is a 4-point problem, I'd probably give you 3.5 points out of the total 4. So correct on paper is worth a lot. So that's another reason to write this down first. It'll help you with the partial credit. And really, you're just thinking in stages as you build this out. It helps you think of what should go where to solve the problem accurately. So next one is, among the eggs that hatched, going along the same lines that we did before, the eggs that hatched was 129, and that's our denominator. What percent were in a cold environment? Well, there's 27 in the cold environment, but among the eggs that hatched, there's only 16. We have to use that strict 16 right there. And that would be the answer on this one, times 100%. Go 16, divide by 129, times 100. We come out to a really smaller percentage, 12.4%. So the hot environment, mimicking the actual mother python, almost a 75% success rate. Cold environment mimics in nature if the mother python just takes off forever, and really low percentage there. Percentage of the eggs that did not hatch or were in a cold environment, that did not hatch and were in a cold environment was pretty low on this. And the percent of the eggs that did not hatch were 30%. But when we restrict to one variable or another, we get some pretty different percentages as well. But these are the main things we're going to look into chapter 3. Again, we actually did spend a lot of time there, and it was a long time ago. This is the kind of the wrap up of what we'd be doing on that first exam question. Well, we have just a couple minutes left, a few minutes. Any last questions or comments at all, folks, about exam 2? Yeah. Just one chapter 3, yeah. I'm going for 4 questions in total. One from chapter 3, one from chapter 4. This is 5-number summary, box plot, IQR rule of thumb, exactly. One from the 5.4, normal distributions, and one from chapter 6, scatter plot correlation. Basically, it's going to be like the 4 quizzes. Quiz 6, I made sure it's pretty targeted this time. I felt like exam 1 and the quizzes we did before it weren't as well targeted as I really wanted them to be. But quiz 6 and quiz 5 are just different scenarios of the last 2 exam questions. So those will be really helpful to get through. I think that's true with quiz number 4 as well. This was the box plot, IQR rule of thumb one as well. Other questions so far? Okay, if questions do come up while you're studying, working on your quiz as well, if you're trying to work on your quiz and get it done soon, but you have questions on it, I take questions on quizzes, I'll be happy to help out. So don't hesitate to reach out. Otherwise, we'll be back to it on Monday's class, and it'll be kind of like exam 1, 4 questions, just different topics. But have a great weekend, folks. Try not to work too hard, but if you do and you have questions, I'll be happy to help out. Thanks.
So quizzes 3, 4, 5, and 6.
I'm not sure on quiz 3, actually. Let me take a look into that one. I think this one was more of an exam 1 topic, actually. So let's see for sure. Yeah, this one was a little bit more exam 1. The IQR is there, but the 5-number summary is missing. There's just 3 parts of the 5-number summary. It's still a good quiz on just a couple parts, but looks like the quiz 4 is really the full one that did the box plot, IQR rule of thumb type stuff. It looks like I didn't actually have any quiz that corresponded to the first problem on the exam. Glad we did it in the class.
Yeah.
I didn't have a quiz that corresponded to, geez, that's really far down, the chapter 3. That's the one that doesn't have a quiz. But take a look at these 2 versions. The first problems on there will be pretty much what you're getting into.
Glad. Good weekend.
Thanks, you two folks.
Okay, so I kind of started it when you were doing the first one.
Oh, awesome.
Okay, did I get these ones right? Cause then there's some down here too.
So standard deviation 7, average fasting 90. Yeah, that looks great.
Okay, and then do I put these ones down here too?
No, these ones wouldn't be the parameters. That's just saying extra information about the problem.
Okay,
So parameters are only when it says average or mean and then standard deviation. So those are the two values we want.
okay,
So the next part, when it says what percent of non-diabetic population Idaho Falls has a fasting blood glucose level in the pre-diabetes range, that's where this comes up. You have to put 100 to 125 here and then put that stuff into the calculator.
oh, okay. So then what notes do we do that's kind of like the same?
I would say go to this 5.4 right here.
Okay, the extra example.
Yeah, the extra example, and actually there's many to hit this 5.4, but both of them are gonna be really good ones.
Okay.
So this one right here, this example 3, is different parameters, but similar kind of questions between 296, 3.04. Yours is, I think it was like 100 and 125.
Yeah.
So you'd be putting 100, 125 for the lower and the upper, those two parameters in there, and using normal CDF.
Okay, so do I keep the 90 here and then put 100 and 125?
Yeah,
Okay,
so this one is a little bit different. If we go to this one. Let's go down to these problems. These problems down below here are also pretty similar. And the one you're looking into looks kind of like this one, except it's on the upper end.
okay. Awesome. Okay, thank you.
Yep. If you have any questions while you're working that one out, don't hesitate to email. I'll be happy to help.
Perfect.
Any questions?
So I just, I was wondering, when are you going to put in the grades for the midterm?
Oh, after I complete grading the quizzes, probably early Friday morning, and I'm gonna pull in the MyLab statistics, then I'm gonna put in the midterms right after. So it's probably gonna be kind of early in the morning on Friday.
Okay, cause,
Well, that was my original intention.
yeah.
I
well,
could delay it a bit.
Well, I mean, whatever works for you, I'm just saying, will that aren't you telling me there isn't like a late policy for quizzes?
Yeah, but there's kind of two things that happen. I don't have a late policy in the sense that if a quiz goes late, then you can always turn it in late and get your full credit. But the due date is like the pacing date. It's
Yeah.
the date at which I would put in a grade.
Yeah.
Another thing to think about though as well is that on the top here on the syllabus, the grade that I'm going to be calculating is based off this table here. So 70% of your midterm grade is just 70% is just going to be your exam 1 because it's the only exam we have so far.
Yeah.
Exam 2 is not going to make it onto there. 10% is the quizzes, and there's 5 quizzes altogether. So if you say missed 1, then that's just going to be like 2 points or 2% of the course. And the rest of it, MyLab statistics, is the 20%.
Well, it's just, I was planning on doing it tomorrow after I got off of work, cause I don't know, I sort of screwed myself up. I told them I agreed that I could work from 8 to 6, cause they're short staff, so. Yeah, I only have I have like an hour lunch, so.
That's rough. Yeah, and doing this kind of stuff in an hour lunch is
Yeah.
kind of like you're not going to enjoy your lunch. That's going to be really hard to do, I'd say.
That and I also like to do my own work on the weekends, cause I like more time on my hands, so I like to actually learn. I've also watched the videos that you posted before.
Yeah.
And just to get a refresher and have it in there, so just remembering and forgetting,
Mhm.
so. But yeah, I was just wondering when you would, put in the midterms, but sounds like regardless, I'll probably be a little late to it, which is fine.
Yeah,
But hopefully,
you know, midterm grades are actually due 5 p.m. on the 21st. So I'm just trying to get them done early.
yeah,
There's nothing that's gonna really hurt me if I do midterm grades on Sunday, actually.
yeah, well, I mean, I don't wanna like disrupt like anything that you're doing, so if this is like a system that works for you, that's completely fine.
Yeah, I'll still do my midterm computation on the 17th. But if you get your quiz in, say by Sunday, I can just make a new edit to that midterm grade, just re-upload the new information, is what I'm saying.
Okay,
So I could still be able to include it.
okay, yeah, perfect, cause I was thinking of doing all that on Saturday
Yeah, I think that's gonna work out then.
and then hopefully get all that.
I'll just update your midterm grade. And you know, this chances are your letter grade that I put into the, we used to call that, what do we call that any longer? Used to be called Bingo Web, where you would register for classes, all that stuff. There's a good chance your letter grade isn't actually going to change by very much. It might just be the same range, but your percentage on Canvas would change just a little bit. So I'll give you that updated grade once I get it on Sunday.
Okay, yeah, perfect. Because, yeah, I'm sorry, I don't wanna like rush like any class or anything like that.
Yeah.
I don't wanna build bad habits, it's just, if I weren't working, I would just be dedicated to like learning as much as I can, but balancing both.
That's tough.
And
Yeah, for
also
sure.
getting, like, right amount of sleep, 'cause I don't wanna go off for 4 hours of sleep while learning something new like this, that's pretty,
That's a different kind of sleep debt you have to pay off later too. Yeah.
but, yeah, we're just, I was wondering when you were both done, but
Okay.
I have a better idea.
Well, have a good weekend. Try not to work too hard if you can help it.
Okay, all right, well, thank you, have a good weekend too.
Thanks. Take care.